Hi Algebra 2 students! This week we're going to be learning about transforming functions, points, and graphs. This skill you will use in every unit in this course. Every unit will learn about a new type of function, and in that unit we will transform that function. Now you should be familiar with the basic vocabulary already because we went over this together. But just to review, what is a transformation? A change in the position, size, or shape of a figure. What is a translation? It's a shift or a slide that can go left, right, up, or down. Now, in order to perform a translation, what we need to be doing to the function or the points is we add or subtract. Next up, reflection. That's a flip or a mirror image. To perform a reflection, what we need to do is multiply by -1. Last, what is a stretch or compression? That's a push or a pull along the x or y axis. To perform a stretch or compression, we multiply or divide. Now, we typically see stretches and compressions just with multiplication because rather than dividing by 2, we multiply by 1/2. So multiply is really the main thing you're going to see for stretching and compressing. Okay, so let's look at this first example. If we want to translate a point 5 units to the right, let's just take a look at the graph. We'll plot the point -3, 4. And label it. And if we want to translate that point 5 units to the right, we just need that point to go directly to the right. We do not need it to move up or down at all. So our y variable will stay the same. It's just going to stay at 4. But what we need is this x constant to go 5 to the right. So if we count 1, 2, 3, 4, 5, or here 1, 2, 3, 4, 5, here's our new point. And where we are now is at 2, 4. Notice all we needed to do to get there is do -3 plus 5. And we've got that over 2 now. Let's look at the next one. This time we're going to take our original point of -3, 4 and go 2 units left and 2 units down. I'm going to look at a new graph. First, I'll write my answer here so that doesn't get lost. There's our point of -3, 4. And this time we want it to go 2 units left and 2 units down. So when we go left, we're going more negative. So we are going to subtract from our -3. And when we go down, we are also going more negative. So we need to subtract from our 4. So our x variable is now -5. Our y variable is 2. To double check that, I could go ahead and graph this point. I could go over -5 and then down, this is at 4. And now I can see, sure enough, it's at over -5 up 2. Let's look at transforming actual graphs of functions. So we're going to use a table to perform these transformations, and then we will graph it. First thing we should do is label some points on this original graph. So I'm going to put those points into a table. And I don't need to label all of them, but I do need to label some key points here. I think if I have these 5 points, that'll give me a clear picture of my graph. So if I label these points, the first one is over -4 down 2. The next point here is over -2 up 0. Next I have over 0 down 2. Next, over 2 up 0. Oops, can't quite see my picture there. Sorry about that. And this last point is over 4 down 2. So these are the points from my original graph. What we're being asked to do with this graph is translate it 2 units up. So take the original and go up 2. Every single point then needs to go up 2. When we're moving up and down, we're moving in a y direction. And if we're going up towards more positives, we are getting bigger. So we need to add 2 to our y value. So I'm going to now just look at these 2 rows, and I am going to add 2 to every number in that y row. -2 plus 2 is 0. 0 plus 2 is 2. -2 plus 2 is 0. 0 plus 2 is 2. 0. Now I'm going to plot my new sets of points. So I'm not changing my x values because I'm not moving horizontally. I am only moving up 2. So I'm going to use these sets of ordered pairs and plot them on my graph. Change colors again. So over -4, up 0. Over -2, up 2. Over 0, up 0. 2, 2 is my next point. And my final point is over 4, up 0. Now I can draw in my shape. I should maintain the same shape. And sure enough, it matches the same as the other one. It's just being shifted up 2. We've done a lot of practicing with translations. Let's practice some other types of transformations. We'll start with reflections. We had said earlier, and you had seen in your Desmos activity, that a reflection we need to multiply by -1. It's a flip over the x or y axis. So we're going to reflect now across the x-axis. So if we take a look at our picture here, we'll notice that it's going to flip up and over this x-axis. It's going to give us a W shape. So I need to use that same table of values to get myself started. So I have x and y. Remember, I have these 5 points that I've labeled, and I will use them in my table. So -4, -2, -2, 0, 0, -2, 2, 0, 4, -2. Now let's try to figure out which points are going to have to move, or what values are going to have to move, the x values or the y values. If I'm predicting that it's going to, or I know it's going to flip over the x-axis, and so what's going to happen is I'm going to end up with like a W this way. Okay, notice this point is going to have to flip up and over the x-axis. For that point to flip up, it's the y that has to change, right? For it to go up. because up is always in the y direction. So I need to take all my y values and multiply them by -1. So let's add that row on our table. We are going to take our y values and multiply them by -1. Let me clean up my space here. I lost a few lines along the way. It's okay. All right, -2 times -1 is +2. 0 times anything is 0. +2, 0, +2. Now I'm going to go ahead and graph my new sets of ordered pairs, keeping the same x value because x is not changing. I'm not reflecting horizontally. I'm not shifting horizontally. And I'll find a new color to plot my points in. I'll use that pink again. So this time over -4, up 2, over -2, up 0, over 0, up 2, over 2, up 0, over 4, up 2. Connect these. And do you see a mirror reflection between the original and your new one? I do too. We did it right. Good job, us. All right. Last type of transformation we're going to practice is a stretch. So remember, stretches we multiply, okay? So if I say something doubles, it stretches. I multiply by 2. So this time we're going to do a vertical stretch of 2. When you see vertical or up or down, do you think y value or x value? Good, y value. So we're going to take our y value and multiply it by 2. Let's start that table again with our original points. Over -4, down 2, over -2, up 0, over 0, down 2, over 2, up 0, over 4, down 2. And we said we need to take our y and multiply it by 2. Change colors. -2 times 2 is -4. 0 times anything is 0. -2 times 2 is -4. So now I've got these 2 values to make up my ordered pairs, and I'm going to start plotting them on my graph. First, over -4, down 4, over 0, or I'm sorry, over -2, up 0. So stretches and compressions sometimes will overlap. They're not going to look as neat as the reflections or the shifts do. Over 0, down 4. Over 2, up 0. Over -4, down, or I'm sorry, over, that should be a +4, down 4. Let's take a look at this. Connect our points. All right. We can see that this has been stretched, like it's being pulled down. All of those points have been pulled farther down along the y-axis there. It has been stretched. Let's look together at one application problem. It says the graph shows the cost of painting based on the number of cans of paint used. Sketch a graph to represent the cost of a can of paint doubling and identify the transformation of the original graph that it represents. Well, we actually already have the graph sketched there. The original graph is in blue, okay? So this is the original one, okay? And we do have the sketch there, but let's look at how did we get that there. It says that the cost of the can of paint is going to double. What does double mean? Multiply by 2. And it's the cost that's getting multiplied by 2. Notice the cost is on the y-axis. So this is going to be just like our previous example, where we would take points from our table. So I have 0, 0. Should label my x and y. And I don't need to label every point. 220. Especially for a linear function like this, I could probably just label a few. 440. And it says that the cost, the y value, is doubling. So I simply take these y values and I double them. 0 times 2 is 0, 40, 80. And if I go ahead and plot those points, I ran out of room for the 80, but 2 points on a linear function is enough for me to sketch it. There's one more question here. It says, identify the transformation of the original graph that it represents. So when we hear something doubling, when we're multiplying, that is a stretch. And we stretched it on the y-axis, so it's a vertical stretch. When you name your transformations, you always have to say what transformation and what direction. We also want to say how much. What number did we multiply it by? 2. A vertical stretch of 2. All right, so a reflection question for you to work with is to describe 2 ways to transform 4-2 to 2-2. There are 2 valid ways that you could translate or transform, I guess, because it's not necessarily just a translation, this point 4-2 over to this spot of 2-2. So think about that, see if you can come up with the 2 ways. And then start video 1.9 and we'll talk about families of functions.